kind of an old section. You guys have seen this before in the past. Just a couple of things I want to touch on here. Section 7.2, Pythagorean theorem, good old pthag, and its converse. Pythagorean theorem, most of you guys know is a squared plus b squared equals c squared. Although there are actually words to the theorem. The sum of the squares of the two sides of a right triangle is equal to the square of the hypotenuse. So if you take the two shorter sides of a right triangle and square those, add them together, that's the square of the hypotenuse. So most of you are just going to remember a squared plus b squared equals c squared, although there is actually stuff that builds up to that. So certain numbers we can plug into the Pythagorean theorem, a squared plus b squared equals c squared, and they'll always work. We call these numbers Pythagorean triples. So Pythagorean triple is a set of positive integers, so they're whole numbers, that satisfy a squared plus b squared equals c squared. And so you see I kind of gave you some examples of what Pythagorean triples would be. 3, 4, 5. If I take 3 squared plus 4 squared, that will always add up to equal 5 squared. 5, 12, 13. 5 squared plus 12 squared will always equal 13 squared. And 7, 24, 25. So those are Pythagorean triples. They'll always be true. If you ever see them on a triangle, if also you see a right triangle and you have side lengths of 3 and 4, you know the hypotenuse has to be 5. If you see a triangle that's got a hypotenuse of 25 and a leg of 24, you know the other leg has to be 7. So there's little things there. You can try to commit them to memory. If they help you out, then great. If not, we have ways to do the work and not have to worry about having that stuff memorized. But just a little helpful hint there if you need it. The converse of the Pythagorean theorem. One of the things we'll take a look at in some of the examples that you'll see in this section. If the sum of the squares of the two shortest sides of a triangle is equal to the square of the longest side, then you know that the triangle is a right triangle. So basically, if I try to use the sides of the Pythagorean theorem and both sides are equal to each other, that means you've got a right triangle. If they're not equal to each other, then it's not a right triangle. So we'll take a look at that here in a second. So our first example, can 6, 8, and 10 be the lengths of the sides of a right triangle? So we just have a random triangle. We've got side lengths of 6, 8, and 10. Is that triangle going to be a right triangle? Well, we can apply our Pythagorean theorem to that and see if it holds true. So basically, I'm going to set up a squared plus b squared and set that equal to c squared. Remember, c represents the hypotenuse. That's the longest side of a right triangle. So here where we've got 10, we're going to use that for c. 6 and 8 can go in for a or b. It doesn't matter which one. So if I have 6 squared plus 8 squared, the question is, does that equal 10 squared? Well, here we've got 36 plus 64 equal to 100. Well, I know 36 plus 64 is 100. So since both sides are equal to each other, I know that this has to be a right triangle. In the second example, we want to check pretty much the exact same thing, except now with 3 different side lengths, 4, 7, and 9. So again, we're going to be working off of a squared plus b squared equals c squared. The longest side that you have within your list. Okay? If it's not in order from least to greatest or greatest to least, make sure you find the longest side. That's going to be your value for c. So here I would have 4 squared plus 7 squared equals 9 squared. That gives me 16 plus 49. That gives me 81. 65 does not equal 81. So I know that this is not a right triangle. Not a right triangle because it doesn't hold true with the Pythagorean theorem. So that's the nice thing about pthag. It's the one equation that you know, hey, it has to work exactly the right way for right triangles. So The last two examples that we've got here on this board, just, hey, you've got some right triangles, we know two side lengths, what's the length of the third side? So anytime you know two sides of a right triangle, you can always find the third side by just using Pythagorean theorem. So here the side I'm looking for is my hypotenuse, so that's C. So I know here that 8 squared plus 12 squared has to equal C squared. So square both numbers, we've got 64 plus 144. Add those up, we get 208 equals C squared. We don't want the value of C squared, we want just the value of C, so to get rid of a square, we take the square root. So here I've got C. 208, not a perfect square. One of the things that we'll work on, and you'll have seen probably from the first section we've already done, is that we're going to work on simplifying square roots again. So 208, I know that's 4 and 52. I know that 52 is 4 and 13. Well, I can take the square root of both 4's. Square root of 4 is 2. So now I've got 2 times 2, which is 4. 13 I can't square root evenly, so I put it back underneath my square root symbol. So here's the length of my hypotenuse. And I'm sure you'll have questions on this. This is stuff that we'll work on in class as well. By the way, if you want to work on these before we get started, hit the pause key. Here, we know the hypotenuse this time, it's 15. We want to find the length of the height of your triangle here, which we have labeled as B. So we're going to go 9 squared plus B squared equals 15 squared, kind of squishing it in. So here we've got 81 plus B equals 225. Go ahead and subtract the 81 over. Oops, B squared. So we've got B squared equals, what's that, 144. Take the square root. We know that B has a length of 12. So those are some of the basic examples that you'll see, some of the different types of problems we'll work on. There's one last type of problem we're going to take a look at, and you're going to love it because, of course, it involves the coordinate plane. You guys love the coordinate plane. Triangle ABC has vertices at -3, 6, 5, 5, and 3, 2. The big question is that triangle going to be a right triangle? So I drew a little sketch over here, just kind of rough sketched it out. The key thing is going to be to find the lengths of all 3 sides. And if we're on the coordinate plane and you got to find the lengths of 3 sides of the triangle, you know that means we're going to have to use the distance formula. So you can see we've done some work here, found the length of AB, the lengths of sides BC as well as AC. Once you find those 3 lengths, it pretty much goes back to just what we did in the first slide. Now that I have those 3 lengths, use your Pythagorean theorem. Does it hold true? That was the eraser that just fell. So you'll see down here in the corner, I've got set up A squared plus B squared equals C squared. Notice that I didn't take the actual square root of any of the numbers. They would come out to be decimals, and frankly, since we're going to put them into the Pythagorean theorem, we really don't need to worry about the decimals. Things will work out swell here in a second. Square root of 65 is my longest side, and that's going to go in for C. So the square root of 13 squared plus the square root of 52 squared equals the square root of 65 squared. The nice thing here, when you square root, they cancel each other out. So I've got 13 plus 52, that does equal 65, which is good, because that tells me that my triangle is a right triangle. Again, if the 2 sides were not equal to each other, then it's not a right triangle. So that's pretty much the notes for section 7.2. Hope it didn't take too long. Go back and rewind and check stuff out that maybe you weren't sure about, or stuff that you need to go back and recopy. And I will see you in class tomorrow.